Systems review, take 3. Yes, take 3, unfortunately, because I messed up. I got to problem 4 and realized I wasn't recording the last time I messed up. So, bear with me, folks. It should be perfect this time. Here we go. So, you're going to be allowed to use this review on your quiz, so be sure that you make any necessary notes that might be helpful to you. When you take your quiz, you're going to staple this review to your quiz and turn them both in to the turn-in folder as normal. If while we're doing this, if it's going too fast and you need it paused so that you can get things written down, please ask the person in charge, the staff member in charge, to pause the video so that you can get caught up, to make sure that you have the notes that you need to be successful on the quiz. Alright? You're not required to write down every single thing that I put up here, but more than just answers, because that's not going to be very helpful to you on your quiz if all you wrote down were the answers. If you worked on it some on your own, please feel free to erase and change things if you had a wrong answer, because I don't want you to use bad information to help you with your quiz. Alright, so this is all about systems. We are not doing any inequalities on this review or quiz, so you don't need to worry about shading. So the first problem says that we are solving the system by graphing. So even if you could come up with the answer in a different way, the problem, the question, the request is to solve it by graphing. So to solve it by graphing, we're going to graph both lines and then find the intersection point. So where do they cross? You're not just going to find it, you're going to actually tell me what it is. Simple enough, right? Well, hopefully simple enough if you remember how to graph. So in this case, I'm going to take that first equation and I'm going to write it in red over here since I have lots of space. And that first equation, the slope is -1/4. It is in slope-intercept form because the y is by itself, and the y-intercept is 4. Now I'm ready to graph that. Remember that we start on the y-intercept. So the b is the y-intercept, and that's going to be where we start. In this case, the slope is -1/4, so we're going to go down 1 and to the right 4. We could also go up 1 and to the left 4, because one negative in a fraction makes the entire fraction a negative. So we're going to connect and extend that line, and then I'm going to graph my second equation. And my second equation is y is equal to x minus 1. Now you don't have to rewrite everything. It may be helpful for you to write down what your slope and intercept is. If you feel confident graphing without writing that down, that's completely fine, as long as your graph is correct. So -1 on the b, and then from there we use our slope. And in this case our slope is a whole number. Anytime the slope is a whole number, the over part is a 1. So from -1 we're going up 1 and over 1. And I can continue to follow that slope. That allows me to make a nice straight line, or closer at least, and see exactly where my intersection point is. If my line is sloppy, I might not give the right intersection point. So in this case, they cross at 4, 3. That's the x and the y. And if you want it to confirm, then you could plug 4 in for the x's to find out that the y equals 3 in both equations to confirm it works. So hopefully you got that all written down, or as much of it as is necessary to write down. And we're ready to move on to number 2. Again, speak up if you need to pause to get something written down. Or if you have a question, one of your classmates can probably answer it. All right, here we go, on to number 2. Okay, number 2 and 3 are solving by elimination. We did, oh gosh, probably altogether about 40 problems of elimination on Tuesday and Wednesday. So lots of elimination problems, some independently and some that we did on the board together. So hopefully this isn't completely new to you. First, elimination means we're getting rid of something. So I can't solve as long as I have both x and y. So I'm going to try to put these two equations together in some way in that either the x or the y is eliminated. So first take a glance, and if one of the two variables happen to be opposites like that, yes, then I don't need to multiply first. That makes that problem easier. So please don't make an easy problem hard by multiplying when you don't need to. So we're ready to add these two lines together. Keep in mind I say add, but you have to pay attention to sign number rules. So 2x and negative 3x, negative 1x, or just negative x. Y's would eliminate. Negative 6 and 7 makes 1. Then we're going to divide by negative 1, and x will be equal to negative 1. So we're not done yet. Now we need to find the y. For each system, you're going to have an x and a y as part of your answer. So we plug the negative 1 in for the x. So I'm going to rewrite that first equation. I don't always rewrite it, but just so you can really see what's happening. And then where the x is, we're going to replace that with negative 1. Notice we're substituting negative 1 in for the x. The x is no longer there once negative 1 gets there. Just like there's a sub in my room today for me, if they are there, I'm not. So once you plug the negative 1 in, there is no more x. So then I have negative 2 plus 4y is negative 6. So all I did on that step was multiply 2 times negative 1. Now it's a two-step equation. Should be familiar territory. So to get rid of negative 2, I will add 2 to both sides. Now we have 4y is equal to negative 4. So opposite signs subtract, bigger number wins. Divide by 4. Hopefully you know those sign number rules. If you're a little sketchy on those, be sure you utilize the calculator. You can use a calculator on the quiz, so please use that to your advantage. So then our final answer, when we do negative 4 divided by 4, we get negative 1. So in this case, x and y happen to be the same number. So our final answer for number 2 is negative 1, negative 1. All right, number 3. Number 3, we are not so lucky as to just be able to add them together right now. Now, it's your choice. You could try to eliminate the x by multiplying the top line by 9, or the y by multiplying the bottom line by 2, because 2 times 7 would make positive 14. Now, so that we keep the numbers a little bit smaller, I'm going to choose to multiply the bottom line by 2. Now, if you multiply the top line by 9, I promise it still gives us the same answer. This one we have two good choices. We don't always have two good choices. We do not need to multiply the top line if we're getting rid of the y's. We leave it alone. I'm just rewriting it so they'll be lined up. The second equation, 2 times 9, I've got 18x. 2 times 7, 14y. 2 times negative 13 is negative 26. Then we're going to put those two equations together. I see, yes, my y's eliminate. If something doesn't eliminate after you've multiplied by the wrong number or the wrong equation. So in this case, yes, the y's eliminate. This is a negative 1 and an 18, so 17x. When I add negative 25 and negative 26 together, negative 51. Now it's just a one-step equation to find x. We're dividing by 17. When I'm dividing, if there's one negative, it's automatically negative. It's not because it's bigger, just automatically negative if there's one negative in division. Once again, we have the x, so we're going to replace the x with the negative 3. Now this up here says negative x minus 14y is negative 25. This could be a little tricky. We are replacing the x, which is just this part. So this extra negative is going to be hanging out there, like two of them, which is a little awkward, right? But remember what negative x means? It means negative 1 times x, right? So this means, when I plug it in, that this is negative 1 times negative 3. So we're like the opposite of x. So negative 1 times negative 3 is 3, minus 14y is negative 25, and then it's two steps. So subtract, and I get negative 14y is now equal to negative 28. And when we divide, with two negatives, we get a positive. So my final answer, I've really run myself out of room. My final answer is negative 3, positive 2. And if I was a little uncertain because of how things went with that negative x, if that kind of threw me off, instead you could have substituted the negative 3 in for the 9 and used the second equation instead. Or we could check our solution in that equation to be sure that it's right. So 9 times negative 3 would make negative 27. And 7 times 2 makes 14. And if I put those together, it does equal negative 13. So it does check. Alright, so I'm going to make a separate video for the backside because sometimes I have trouble uploading when I make it too long. Alright, so take a moment to get caught up and catch your breath.